Okay, let's go.
Good afternoon, everyone. My name is Wandwali Joshua, a teacher of mathematics. I want to help candidates outside there and with A-level mathematics. So here, the content we are sharing is coming from mathematics A-level presentations. And we are going to basically deal with mathematics. I'm starting with paper 1. So paper 1, I'll be moving in different items, one at a time. So this presentation, I'm going to work with the items coming from section A. So in section A, that is the first item in paper 1, and it has the following topics. We have geometry, trigonometry, and then vectors. As you are well aware, the new curriculum comes with the items which are scenario-based. So this scenario which comes in section A is going to file the following topics 1, 2, and 3, which are put in front here. So a scenario is simply an item which comprises of one introduction, what we call a background. It has characters which are playing or the actions. Then it has support which help a candidate to easily apply the knowledge in class. Then it has what we call the conclusion, and then the tasks there. Each time we are setting, also look at the basis of evaluation, it is and so forth. So I'm going to work with some mock samples and then give you a presentation on how some solutions can look like. So I am starting with the mock bottle from the school, internal mock, Mbale Secondary School, item number 1. So item number 1, I'm going to read the item. Then our screen will also be showing this item. Then after I show you the presentation. So let's go through. The item says, a certain urban planner working in a fast-growing city in Uganda has advised the city council. The council needs to plan the construction of a new stadium to encourage sports, especially football. The city engineer has designed the location of the new stadium to be in the area bounded by the equation x squared plus 4y squared minus 2x minus 2 minus 16y plus 13 equals to 0. According to the grid reference system in the city, x and y are measured in kilometers. To balance construction and design, the main field will be made at the central point with the two training fields at the focal points of the area represented by the elliptic curve. So they have given us the equation representing the curve, which is an ellipse. So if I am to summarize the given information, we have the curve x squared plus 4y squared minus 2x minus 16y plus 13, giving us 0. And to candidates who have studied geometry, we can easily know how to define this curve. This curve represents an ellipse, and they are saying to balance the construction and design, the main field will be made at the central point of that. So meaning they want us to use this, and we get what we call the central point. The central point. And then they also want us to find the focal points. That is for the first paragraph we've read. And they have said, the urban plan analyzed the given equation and discovered that 2 roads in the northern and southern direction to be constructed. The roads pass along the directions of the location of the stadium. The engineer wishes to know the location of the main field, training fields, and where the 2 roads will pass. So the engineer wants this point, and also wants the directrices. So these are the 3 concepts that are taught under this curve, this type of curve. So I want us to give in the first way what these 2 paragraphs mean to us. And when we read it to add, I think there is another information which will come after based on the tasks, because these online presentations, we may not have time to record all what is here before we finish. So already in the scenario, we've identified something, and according to the task, they wanted us to help the engineer to know the exact positions of the main field, training fields and the equations of the two roles. So let us handle the first task of this equation. So we are going to interact with this equation. We generate the center, we interact and get the focal point, and then the directrices. So it is what I want you to follow in this. So task A, this is item 1. Candidates are expected to organize their work, because here we look at presentation. We don't look at how fast you are going to get the solution, but how you present your work from the beginning up to the end. So 1, we are going to use x squared plus 4y squared minus 2x minus 16y plus 13 equals to 0. So this is now the equation of an ellipse. So to get the center, we are going to express this equation in the form x minus h squared divided by a squared plus y minus k squared divided by b squared, giving us 1. The moment we can have this, then we can easily understand more on how to generate these 3 points. So to generate the 3 points here, 1, the center will be at the point h, k. Remember, here we are measuring everything in kilometers. Then we are going to have the point we call the focal points. The focal points will be at the point, because of the center, if the center is not the origin, so this will be h plus or minus a times a units, and then it will be along k. This is where, if the ellipse is a horizontal one, if it is a vertical one, then it will be h k plus be. E is called the eccentricity, and then we have the directrices. So the directrices, we are going to have the equations. If it is a horizontal one, then x, the equation will be x equals to h plus or minus a divided by e. And if it is a vertical one, then y is equal to k plus or minus b divided by e. And that. So we can now go into this. So using that equation that we have analyzed the 3 points, we are going to now group these terms, the x together. So we are now in the solution. We shall have x minus 2x grouped together. Then we shall have 4y squared minus 16y also grouped together. Then plus our 13 equals to 0. Then this equation here, we are supposed to tell when x squared and y squared are all having the coefficient as 1. So this one has nothing big to do, but here we see 4 is here as a multiple of y squared, so we need to remove it out. We are not going to divide, we are going to simply factorize it out, so that here we have y squared minus 4y, then plus 13 equals to 0. Complete squares here. This one will give us x. The half of negative 2 is negative 1. So this will be x minus 1 square minus the square of this 1 is 1. So this one, when you fully solve this, you get that. So we are just using completing squares to have, we are moving to this form. So plus 4 into, can we work out with the idea here the same as this? So this is y minus half of this is a 2. Then square minus the square of this, and that will be 4. Then plus 13, giving us a 0. So when we work out the algebra here, we have x minus 1 squared minus 1 plus 4 into y minus 2 squared minus 16 plus 13 equals to 0. So from here, we can now have x minus 1 squared plus 4 y minus 2 squared, giving us, I think all this we can collect it to the right hand side, negative 1 plus negative 16. The answer we get here is negative 17. When we add here, we get negative 4, the terms independent of x and y. So we can take this the other side and we have it as 4. So the negative 4 contributing from this and that is coming to the right hand side, and that means we are going to have a positive 4 to the right hand side. However, we are interested in achieving this form, meaning we need to find a way of getting a 1 here. So that will be by dividing a 4 in both sides. So when I divide here by 4, I'll get x minus 1 squared divided by 4 plus, when I divide the 4 here, this 4 will disappear. So I'll just get this term out of 1. And this one, when I divide by 4 here, I get a 1. So I have now generated this form, and I can just compare with this and then generate. Now, since the value of a here is bigger than b, or the value at the denominator here as a squared is bigger than b squared, this one is called a horizontal ellipse. So horizontal ellipse extends more along with the horizontal axis. So for this matter, then we are going to have the center. So our center, we are going to have the center. The center is going to be now HK, which I believe we can now just compare. This is H and this is our K. So this is going to be 1 and 2 kilometers. And then we can have the foci. So the foci here, we are going to have H, so which is H plus or minus A times E, and then we are going to have here along with the K. However, we don't have the value of E, but we know the relationship that using B squared is equal to A squared into 1 minus E squared. And from here, when you compare, the value of A squared is equal to 4. The value of B squared is equal to 1. So A is plus or minus 2. And then B is also plus or minus 1. But you can use the arbitrary positives there. So when I put here B squared, I get 1 equals to A squared is 4 into 1 minus E squared. So if I get the eccentricity E, the eccentricity E can be now generated from here as can divide the 4, or it is 1 minus a quarter. I hope when I try to divide a quarter, and this side will be 1 minus that, so that will be the suitable solution for E. So the eccentricity here is going to be, the E squared is 1 minus a quarter. So eccentricity will be, of course, the solving of this is 3 over 4. So it will be the square root of 3 out of 4, which simplifies to root 3 divided by 2. Because 4 is a square number, so under the square root, it will be that. So after getting the eccentricity, we can now easily substitute to get the value of the foci. So meaning the foci, we are going to have the coordinate as h, which h is 1. The h is 1 plus or minus AE. A is from here. A is 2. So the plus minus is always inbuilt here. So that is 2 times root 3 divided by 2. This is the eccentricity. This is A times E. Then K is 2. So my foci will be 1 plus or minus, I think this is 2 will disappear. So that is root 3 and 2 kilometers. These are 2 coordinates. We have the one coming from a plus and one coming from a minus. So we now have the foci. And lastly, we can look at the directrix. Directrix or directrices. So it is a horizontal ellipse, so that will be H plus A divided by E. So my X will now be H is 1 plus or minus. Our A is from here. The value of A was 4. So A squared was 4. So A is 2. So that is 2 divided by root 3 out of 2, because this is the centricity. So when you solve the directrices here, we have 1 plus or minus 4 divided by root 3. When we are simplifying here, this denominator comes on top. So this is now in kilometers also. Now, what have you observed here? We are going to make a conclusion. So in our conclusion, we have that this one represents the central point of that field. The field is going to be at the central point, that's the main field. Then the training fields will be at the points which are indicated by the focus. And then lastly, the roads which will be matching that field. So let us now make a conclusion and say the main field. So we are now coming to the conclusion of our task A. Conclusion: the main field will be at point 1 2 kilometers. The training fields at 1 plus or minus root 3, then 2 kilometers. And then lastly, the roads will pass through paths represented with the equation we have calculated, which are the other side. And that is x equals to 1 plus or minus 4 divided by root 3, all measured in kilometers. So this presentation for task A ends here, and the candidates are expected to always try to understand what the scenario is all about, then use the support which is given in the form of maybe an equation, or it is given in terms of in words, but still they bring learning which has occurred in classes. And all the calculations, you must always come to the conclusion, because you are trying to use the concepts to have informed decisions about the tasks. So that is part A of that task. So we can now have something. You can play this video. And at the end, where you don't go, you can always pause, write something, then you consult. But have the question first. When you have the question, it helps you to proceed with the questions very well and the solutions or the presentations here. So we are going to task part B and C at the same time. So
okay, let's go.